Hello, we're going to be learning how to graph in slope-intercept form. This is our equation, y equals mx plus b. It's the one in our classroom near Jabba the Hutt. That's what I refer to it as. So recall, how can you tell if an equation is linear? So in a graph, it looks like a straight line. In a table, you have the constant rate of change for your slope. In an equation, the highest exponent is 1. You can also solve to get it into standard form is another way to check. You can graph any equation using a function table, right? Just like this one. Notice that has an exponent higher of 1, that's an exponent of 2, which means it's not linear, it's something else. We pick our values for x, right? We pick the ones that can fit on the graph, so usually between negative 10 and 10. If it's a smaller graph, negative 5 and 5, right? You want some negatives, you want some positives, you want a 0 in there. So we could pick, let's go with negative 1. We'll go 0, and then we'll go 1. We'll see what it looks like from there. So we can substitute these in. So y equals this. All I have to do is evaluate. Order of operations. Negative 1 times negative 1 is a positive 1. 1 times 3 is 3. So we have y is equal to 3. Negative 1 times negative 1 is a positive 1. And then plus 17. So we just add those together. 17, 18, 19, 20, 21. So our output would be 21. All right, here we go. So this time we're plugging in 0. We picked 0 because 0 is a good one to pick because what happens is usually everything gets eliminated. I can tell you right now the answer is 17. How do I know? Look, 0 times 0, 0. 0 times 3, 0. 0 times 0, 0. 0 plus 0, still 0. Plus 17 is just 17. So that's what's nice about 0. 0 is always a good one to pick. It makes the mental math go pretty quick. So it's usually your constant term, whatever is not with a variable, usually. And then you can plug in 1. You're going to notice 1 times 1 is 1. 1 times 3 is 3. 1. Guess what? We're going to get 21 again. Which makes sense. It's kind of, we got a curve. It's going to kind of happen again. So there's 3 forms. We're going to start with slope-intercept form, which is right there. Our y equals mx plus b. Standard form we will also see today, and it's very nice and helpful with our intercepts. Now, point slope form is the best, most versatile form, right here, this one. It looks a little crazy. It looks almost like the distance formula. I'm a math. Because it kind of is. So right now, we're going to focus more on slope-intercept form, a little bit of standard form. We'll get to point slope form later. Sound good? How to graph slope-intercept. It's easy. The y stays, the x stays. The 2 numbers we look for are this m and this b. So the m is with the x, the b is not. What is b? Well, technically, if you look at the Jabba the Hutt, it says where you begin. So it's where we start graphing. We always start over here. Why do we start on the right? It looks backwards. Well, yeah. It's our y-intercept. So whatever this b is our y-intercept. What that means, and if you want to use a little highlighty here, right? If we're plotting the y-intercept, this b term will be somewhere on this line. It's not that line exactly, but there will be a dot somewhere on that line at whatever this number happens to be. And I like to highlight in this sign out here because if that's a -2, we put it at -2. If it's a -5, we put it at -5. That's where we start. There's our dot. We always start there. Then, our m is our slope. So it's our rise and run to the next point. So if you are color coding different colors, you may if you want. But this, if you don't have another highlighter, don't worry, you don't really need to. But if you have multiple colors, because some of you do, this M right here is your rise and run to the next point, which means we can make it look like a fraction by making it, and we can put a 1 under it, whatever that number happens to be, right? Whatever that number is, we can put a 1 under it. So we have our rise and our run. So our rise is when we're going up or down, and our run is when we're going left to right. So it's our rise over our run. Then we connect the points. We don't just connect them all willy-nilly like. We use another piece of paper, line it up, and connect the dots. So make sure you are being precise and using another piece of paper. So how to graph in standard form? Well, there is a way to do it with intercepts, but I'm going to show you. You just make a function table like we did here, right? We picked our x values, substituted in y. So you choose any x value, find the y value by evaluating, plot at least 2 points. Now, I'd go with the solid 3 points. 3 points is good. Or you can change it to y equals mx plus b. All you have to do is solve for y. You can graph it the other way, which is kind of nice. Graphing linear equations. Identify the form of linear equation and use what you know about the form to graph the equation. All right, here's what we're going to do. We're going to graph. So this is number 1 on your paper. So this we're going to need your notes, and you're going to need a random paper, which could be your other page of notes if you haven't glued it in yet. That way you can line up. If you have a ruler at home, use the ruler. But I don't know if you have a ruler, so another piece of paper works. All right, because map testing is coming up February 2nd through 5th. So if you don't have you can't use a ruler on maps test, but you can use another scratch paper. I'm just saying, and you can, if you need. Okay, you can always get more scratch paper. All right, here we go. So our form, what form is it in? That's our goal first. Is it in standard form or is it in slope-intercept form? Well, if you go back and look, this is a good one to look at. Does it look like this one or does it look like this one? Do we have y is equal to something, or do we have our variables, and then a number at the end on the equal sign? Oh, we have y equals mx plus b. So I'm going to write that. What form is it in? It's slope-intercept. First, we start with, this b value, our y-intercept. So our y-intercept is positive 3. So what we're going to do is we're going to go on our y-axis and find positive 3, right there, put a dot. Then we have our slope, right? Our slope is this m term here, this 1 over 2. So we have our rise over run. So we're going to go up 1 over 2, up 1 over 2, up 1 over 2, vertical 1 over 2, vertical 1 over 2. Now, I usually talk about up and over. 1/2 is the same as -1 and -2. Why? Because -1 divided by -2 is a positive 1/2 still. So we can also go the opposite way to get the other side of our line. We can go down 1 and to the left 2. Down 1 and to the left 2. Down 1 and to the left 2. See how we get both sides? From there, line up your paper. So connect those dots with a straight line using a pencil. I would like to be more accurate, so that's why I'm using this. Features of the graph. The first thing you're going to want to look at is it a positive or negative slope? Think back to slope, dude. Puff, puff, positive. Puff, puff, positive. You can also see, oh, look, our m is positive. So it's a positive. The y-intercept, is it above or below the x-axis? There you go. And so you could also put that the y-intercept is above this x-axis. So this crosses above. He has a red nose. Maybe it's Rudolph. Okay. X-axis. So those are kind of the main things we're looking for. But the idea is that it's slope. Oh, is it a straight line? Yes, it is a straight line. So it's linear. You could write the word straight line, but linear means the same thing, and it's less letters. Boom. So it's a straight line. We have a positive slope, and then you can talk about above or below the x-axis. But these are the two main ones they're looking for, if you were wondering what kind of slope it is, and if it's linear or not. Okay, here we go. Form. Okay, which form is it in? Oh, that's a slope-intercept form again, right? So we have our y equals mx plus b, right? So we know it's our slope-intercept. Okay, so if we look first, we are looking for our y-intercept here. So our y-intercept is a -2 this time. Make sure to take the sign into account. A -2, which means we're going down here to -2, and that's where we're going to start from. So we're starting from below the x-axis. That could be something you write for your feature. Then we need our slope, which is this 3/4. So we're going to rise 3 and we're going to run 4. 1, 2, 3. 1, 2, 3, 4. Put a dot. 1, 2, 3. 1, 2, 3. Oh no! I mean, I might put it, but I don't think I'll connect it per se. Now remember, 3 divided by 4 is the same as if we said -3 divided by -4. It'll still give us a positive, right? Negative divided by negative makes a positive, 75 hundredths, but we don't need the decimal. We want this 3 and this 4. That way we can go down 3, over 1, 2, 3, 4 to get the other side. Down, and we're off the graph. Okay, so there is what we have. And then we can connect it. I'll try to do it with my pen. Use a piece of paper. Oh, that wasn't too bad. That wasn't terrible. It's a little wiggly. Yours will look beautiful on your notes because you got a ruler. My technology, my ruler is not easily used. Okay, here we go. This one looks different. Well, if we look at our forms, we have y equals negative 2x. If we look back, y equals something. Okay, that looks good. But there's a y and the x on the same side. No. It's definitely slope-intercept form, but we're missing that y-intercept. Now, what's interesting is we're actually not missing it. They just don't write it. Let's talk about why. So it is slope-intercept. Slope-intercept. So it is our y equals mx plus b. What could we add to something that won't change it, that we don't need to write? Plus 0. That's why they don't write it. Remember, we write as simple as we can be. So our starting point, when they don't write it, is our origin, our 0. So our ordered pair for our y-intercept is at 0, 0. So if they don't write it, it goes through the origin. Easy, okay? And then our slope is negative 2. We can make it look like a fraction, right? We can make it look like a fraction and put a 1 under it. So we have negative 2 once. So we go down 2 over 1. Down 2 over 1. Down 2 over 1. Oh, I forgot the features of the last graph. And then we can go the other way. Now the other way, be careful, it's different. This would, if we divide, we get a negative 2. But if we take 2 divided by a negative 1, we still get negative 2 for our slope. So we can go up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. That way we get both sides of our line. We can then connect with a beautiful straight line. Use a ruler, use a ruler, use a ruler. I know I say it. I hope you're watching and listening so you know to use a ruler and make it a beautiful straight line. Ooh, that was decent. Okay. Notice I'm going all the way through the graph. I'm not just kind of making it right here and tiny. Make it extend all the way through that graph with arrows at the ends. All right, so we forgot to do the features of the last one. So I'll do the features of this one, and you can kind of go back and fill that one in. You can ask me in class to check your answers tomorrow. I'll tell you what they are. So if we look at our slope here, that is a negative slope. So this time we have a negative slope, right? Slope dude is nice negative, nice negative. It is a linear function, right? Because it looks like a line. It's a straight line. We got a negative slope, and you could put that it crosses the origin. Our origin is our 0, 0. We could write origin. Sorry, my handwriting is not great in this program. Okay. This one, what form is it in? Oh, well, it doesn't even ask us. Okay, cool. So we'll just go for it. This one is actually in slope-intercept form. It's in our y equals mx plus b form. I don't know why I didn't write that above. In our y equals mx plus b form. And if we start with our y-intercept, our plus 4, we're going to start at positive 4 on our y-axis. Happy! Now our slope looks like it's hiding. But it's not. Our slope is there. That's a negative. What number is that being multiplied by x that we don't write? It's invisible. Oh, 1. It's a negative 1. So our slope is negative 1, right? And we can make it look like a fraction by putting a 1 under it. So it's a negative 1 once. So we go down 1 over 1, down 1 over. Oh, let's do my happy face. Well, no, let's keep going. That's fine. Down 1 over 1, down 1 over 1. Down 1 over 1. Keep going through all the whole graph until you can't go anymore. And remember, we can do the opposite as well. And go up 1 towards our negatives 1, up 1 towards our negatives 1. That way we get the other part of the graph. That way we can connect it and make a beautiful straight line. Oh gosh, that's squiggly. We can make a beautiful straight line with our pencil. use a highlighter and arrows. Lovely. All right, they didn't say about anything else, so we just have to graph it. Moving on. Here we go. Ooh. Guess what? Did you know that this one's in slope-intercept form? Y equals mx plus b. Remember we talked about this. If the b is not written, it's plus 0, right? So that would be like plus 0. We just have a dot starting at the origin. And what's our secret slope here? Our secret slope is a 1. 1 times anything is 1. And we can write a 1 underneath. So we go up 1 over 1, up 1 over 1. This is called our parent function. So this is the most basic equation for a linear function. It goes through the origin, and it has a beautiful slope of 1. We can connect those with a beautiful pencil to make a beautiful straight line. So this is a parent function. This is the most basic, classic linear function. Next. Oh, did you know that's still in slope-intercept form? It's weird. So you're like, but there's no x. You are correct. There is no x. It's hiding. So y equals mx plus b. Now we have to ask ourselves, is 3 the m or is 3 the b? Now some of you might be like, it's the m because it's right after the equal sign. Now be careful though. Even in the last ones, our x has to be there first. Our x is there first. If it's just a constant number, that's our y-intercept. So, nope, too far. There it is. So for this one, our y-intercept is b. It's 3. Now I'm going to go a little bit further ahead here. Where's my happy face? Happy face. So why our y-intercept is 3. No matter what our x is, our y will be 3. No matter what our x is, our y will be 3. No matter what our x is, our y will be 3. How does Miss Iceford know this? Even fractions. So all of those are solutions. How does Miss Iceford know this? Well, if you notice something, are you starting to see the slope of the line? Yes, I've gotten a little too happy. It's a 0 slope. It's a 0 slope. If we were to write this equation in y equals mx plus b form, our m is 0, and then we have our x plus 3. 0 is our slope. 0 times x is still 0. That's why they didn't write it. So this is a horizontal line. If you have y equals a number, horizontal line every time. It's kind of one of those weird ones. And I always like to think of it, it's like in slope-intercept form. We still have y equals something. So it still has a slope. It's just a slope of 0. So don't forget to connect your dots. I don't think you probably did as many as me, and that's okay. You probably shouldn't have. That took a long time. Okay. So we have horizontal lines. That's fine. 0 slope. We remember slope, dude. Ooh, that is an x. That is not slope-intercept form. You know what that means? It's not a function. What do lines look like when they're not a function? It's undefined. Oh no, how dare I say that? So our x is equal to -2. So no matter what our y is, our x is still going to be -2. So our x is -2. Even if our y is 2, -2. Even if our y is 4, -2. Even when our y is 3, our x is still -2 because it says x is -2. No matter what, our x coordinate will always be -2, even in fractions, even in decimals, even at -5.5. No matter what our y is, our x coordinate will still be -2. So if you notice, this is then a vertical line. And if you remember slope, dude, it is an undefined slope. So since we're not in slope-intercept form, it's not. It's a vertical line. So it is linear, true, but it's not a function, which is why we don't have a slope, which is why it's not really in slope-intercept form, technically, because that's x is equal to it. So we have our horizontal lines, our vertical lines. We still have those. They're easy to mix up. Here we go, standard form. So what we could do here is we can make a table. We just pick values, any values we want. So let's make a little table here. Let's pick some x coordinates here. Which ones do we want? I'm thinking if we're picking x coordinates, I'm going to go -2, 0, 2. So I'm picking -2, 0, and 2, right? They said minimum of 2. I'm going to go 3. All we have to do is find our y values. We just substitute them in. Now I picked those. They were on the graph. I'm not picking -8. It's not on the graph. So I picked -2 here, 0, and 2. All we have to do is substitute those in and solve. So we have 3. Give some space. Well, no, you can just write it. We'll write the other part later somewhere else. I'll show you the other method. So if you want to leave this spot blank and write this somewhere else for work, that'd be a good idea. Okay, here we go. 3 times -2 minus 2 times, oh, nope, that's just y. Sorry. Y is equal to 6. All right, so then we solve. 3 times -2 is -6, right? And then we're left with -2y is equal to 6. So we add 6 to both sides. We get -2y is equal to 12 divided by -2. Y equals -6. So we end up with -2, -6. Fits on the graph. Awesome. So we go -2, -6, and we put a dot. So now we do the same thing with 0, and we're going to substitute in 0 and see what happens as we go through. So we have 0 here. 3 times 0 is 0. We can subtract 0 from both sides, which means those are gone. 6 minus 0, 6. 6 divided by -2 is a -3. Okay, so we're going to get a -3 here. So then we graph 0, -3, right there. And we picked +2, so I'm going to do the same thing with a +2 and see what happens. All right, so we have 2. 3 times 2 is 6. We can subtract 6 from both sides. 6 minus 6 is 0. 0 divided by -2, 0. So then we have a dot at 2, 0. Ooh, and you can start to see it. I mean, we kind of had it before. That's why they say with 2 points, you can then go up 3 and over 2, up 3 and over 2. You can go up 3 and over 2. I just like that third point to make sure it looks good on all the sides. So there's our points. From there, take a piece of paper, line it up, and connect them all the way through the graph. Make it beautiful. Oh, that's an arrow. That's not a line. That's an arrow. Okay, there we go. Now, I told you I'd show you another way. Table way is one way. Another way is if this is standard form, we can get it into slope-intercept form by solving for y. So this is a whole different method. You can just solve for y. Then we can graph like we did before. So to get y by itself, we're using our literal equations knowledge. So if you struggled with literal equations, the table might be best. If not, this is a great time to practice. So if we're getting y alone, we need to get rid of the x term first. So we're going to subtract 3x from both sides. That way we are left with a -2y is equal to, now be careful. If we want it into y is equal to mx plus b, we want our x term first. So we're going to put that -3x first plus 6. From there we can divide both sides by -2 to get that -2 away from the y. That way we are left with 1y is equal to, now remember here, we can divide both of those terms by -2. Now you could divide and get a decimal, but we want slope. So we just write it as a fraction. -3 divided by a -2. We can just write it as 3/2, right? Negative divided by negative is a positive. We can just write it as 3 divided by 2x. 6 divided by -2 is a -3. Now I want you to look at this and look at the graph. I want you to look at this and look at the graph. Our y-intercept, where we begin, is -3. And look, -3. Our slope is 3/2. From there we go up 3 over 2, up 3 over 2, up 3 over 2. You can solve for y every time. You can use the table every time. Your choice, whichever one you want. We're going to write the equation of the line in slope-intercept form now. So if we are given this line, and our goal is to write it in slope-intercept form, you may want to remember that our slope-intercept form is y equals mx plus b. Usually I like to start with where we begin when we graph them, is with this y-intercept here. So to find our y-intercept, we look at where the line crosses our y-axis, that vertical line. So where does it cross the vertical line? And if we look, we can see that it crosses right up here at positive 6. So if that is true, then it is a happy positive 6. Positive 6. Now make sure that is a 6. Doesn't look like a B, although they look very similar now that I drew them and see that. Our x, we then need our slope from a graph. So we need to find another lattice point, or a few. So I'm going to use flowers for those. That way you can kind of see the difference there. Let's see, so there's one here. There's a lattice point here. There's a lattice point here. There's a lattice point. Nope, not too far. You can start to see the rise over run from here, which we practiced before winter break. So to get from here to there, we can go up 2. So there's our rise, and to the right 1. So they're both positive. So it'd be 2 once, right? So if we have 2 once as our slope, we can simplify that to a whole number as 2. So we either want to write it as a fraction or a whole number. If you can simplify to a whole number, good to go. Don't write it as a decimal though. Okay. Equals y. Boom. Done. Always double check your slope just to be sure. See if slope dude checks out. Positive. Positive. That too is positive. Awesome. All right, here we go. Number 11, same idea. So we have our y equals mx plus b. Let's start with our y-intercept here. So we're going to see where it crosses our y-axis, which is down here at -1. So our y-intercept is -1. You could put plus a -1, but it's a lot nicer to just put -1. But they do mean the same thing. And then we need our slope, which is the m. And we need to find a lattice point. Ooh. Oh, look there. Oh my goodness, hold on. Let me put the flowers there. There's one. There's one. Our happy face is also a lattice point. It just happens to be, oh, look, there's our x-intercept. But it happens to be our y-intercept. Okay, so from here, notice it's wider than the last one. This one's steeper, so it's a whole number, right? To get wider, we need to make it a smaller slope, which you learned in class. And this one's actually smaller, so small, it's not even a whole number. It's a fraction. All right, so if we do this, we're going down 1. Whoa, I didn't know I could drag and drop the stuff. So sorry. Go with a random flower to the side. Okay, so we can go down 1. So to get from this point to this point, right, we can go down 1, which would be a -1, and then to the right 2, so it'd be a positive 2. We do it again, down 1, to the right 2, down 1, to the right 2. So we have a -1 over 2, which is a -1/2 slope. And you can always check slope, dude. That's a nice negative. Yep, has to be a -1/2. So the wider you have, the more of a fraction your slope is. The steeper it is, the bigger the whole number is. All right, next one. Okay, same idea. You can try it on your own first and then see how we did. But your y-intercept is here. So we have a +2 at the end there, an x, and then all we need is our slope, and we're done. Okay, here we go. Oh, this looks nice and easy, just like we did this a few moments ago. Oh, happy face. This is a lattice point. There they are. So to get from one to the other, you go up 1 over 2, up 1 over 2. But it is a positive slope, so it's a +1/2 slope. All right. Next, we're going to do the same thing, but from a table. So same idea. We still need our y-intercept, and we still need our slope. Good news is, from here, we can just look at this right now, and we know exactly what our y-intercept is. So we are y and x plus b. plus 15. How did I know it was 15? Oh, good question. If we look back at our y-intercept, it's when our x-axis is 0. So when x is 0, what is our y? That's what we're looking for. So to find that from a table, we find when x is 0. Oh, look, there's the 15. Boom, done. That's how we find it. That's easy. You can go through, find the next two, I think. Maybe the next one. I don't remember if the third one has it that nicely. So we have that. Next, we just need our slope. Now, we know it's rise over run from our graph, but if you use your slope notes, it's our change in y over our change in x. So how y is changing, how do we get from 1 to 15, 15 to 29, 29 to 43? I think that's 14. Let me know if I'm wrong, please. Because, 1 plus 14 is 15. Okay, good. And then we check our change in our x. So how do we get from negative 2 to 0? Well, that'd be plus 2. How do we get from 0 to 2? Plus 2, plus 2. There we go. Now we're not going to write 14 halves because we can simplify. What can 14 halves simplify down to? 7. Done. Next, we have number 14 here. So again, we have our formula ny equals mx plus b, correct? And we can see right here, right, our y-intercept is when x is 0. What is our y? Oh, it's also 0. Now, we saw this today, well, yesterday, plus 0. Today for me, yesterday for you. 0, we don't need to write it. So in our final equation, we're not going to write the plus 0. I'm leaving it there so you kind of know where we got that, what's happening. We don't need to write that. All we need now is our slope. So we need our change in y over our change in x. Okay, so our change in y, how do we get from 12 to 8? This time we are subtracting. Watch out for your signs. Subtracting, what is that, 4? Subtracting 4. Okay, so our y is a minus 4. Watch out for where it goes in the fraction. And then our x, we get from negative 6 to negative 4. Oh, this one we are actually adding 2 because we're getting closer and closer to 0. Plus 2, and that way 0 plus 2 would give us 2. So that'd be a positive 2. That can also simplify down to a negative 2x. Boom, done. Awesome. Now, this is not the most beautiful answer. I'll write the most beautiful answer in blue because it's blue. Just kidding. We would just write y equals negative 2x. We don't need to put the plus 0. So this is our final answer because if it's not written, we know it starts with the origin when we graph it, which we've saw. Okay, from here, we don't have a y-intercept. So let's start with what we do have. All right, we can find our slope, right? The change in y over our change in x. So how do we get from negative 2 to negative 5? Well, we are actually subtracting 3, right? Subtracting 3. Okay, so we get minus 3 for our change in y. And for our x, we are adding 5 plus 5 plus 5. Okay, so we'd have negative 3/5. Okay, so we can fill that in to our equation. Now, we can't just leave it blank because it's not necessarily 0. We don't know that. We can't put another variable in there. Don't do that either. So we actually have a few options. You could substitute in any ordered pair and solve for what b would be, but that's a little bit more complicated. If we use our pattern backwards, remember our goal is to find x when x is 0. Now, it's not going to be to the right. It'd be to the left, and you can already start to see, well, it would be here, would be 0, right? 0 plus 5 is 5, right? So you keep with your pattern, which means we have to find out what minus 3 would give us negative 2. What minus 3 would give us negative 2? And I think that's a 1. Yep, so it'd be a plus 1. So you may have to go back a little bit or forward a little bit just to find your pattern. So wherever x is 0, it is what our y happens to be. So if you want to do a little highlighter action, that's how we found it. We used our pattern backwards. Oh, sorry. This is our final answer, this whole equation. I don't know why I didn't highlight it. I circled it. It's fine. Okay, so write an equation of the straight line that passes through 0, 3, and 4, 0 in slope-intercept form. Okay, so in slope-intercept form, we need our y-intercept. Now we know our y-intercept is when x is 0. Which of these ordered pairs is x 0? X is 0, this one. Since our x-coordinate is 0, what is y? Y is our plus 3. Now that doesn't mean 4 is our slope. Don't do it. It's going to be on there as a multiple choice problem. Don't click it. Be careful. In order to find our slope, we need our change in y over our change in x, which is our slope formula, right? Our slope formula is a y2 minus y1 over x2 minus x1. And then we solve. So we have our y2, which is 0, minus 3 over 4 minus 0. So we have 0 minus 3 is negative 3, 4 minus 0 is 4, so our slope is a negative 3/4. So we can still use our formula. Awesome. The given equation, 2x minus 3y is equal to negative 18. Find the x-intercept, y-intercept, and slope. Okay, here we go. Are you ready? X-intercept, right, is when x is a number and y is 0. Y-intercept is when x is 0. What is our y-coordinate? And then our slope, we're going to have to solve for y. You could solve for y if you wanted to. Oh, I'm going to do a different color so I can color code this. Solve for y. Okay. So how do we do this? Great question. I'm going to color code each of these. So basically for the blue one, for x-intercept, we want when y is 0. We substitute in 0 for y. That way we can solve for what x is. So when we solve, we get 2x minus 0. Do we even need to really write the minus 0? Not really, because you could add 0 and it wouldn't change anything. So negative 3 times 0 is 0, which we don't really need anymore, which makes it nice and easy because when we divide by 2, x is equal to negative 9. Done. Next one, we do the same thing, but plug in 0 for x. So 2 times 0 is 0, so we just have negative 3y is equal to negative 18. And I'm going to tell you right now, this is a very helpful way to graph in standard form. So this is a good one to know. Negative 18 divided by negative 3 is a positive 6. So there's our y-intercept. Now to find our slope, the easiest way to do that is to solve for y. So that way we get into slope-intercept form. So if we have 2x minus 3y is equal to negative 18, and we want to solve for y, we have to get rid of the 2x from both sides. We have negative 3y is equal to negative 2x minus 18. If we divide everything by negative 3, we get y is equal to, okay, we divide each term by that negative 3. So the negative 2 divided by negative 3, we don't actually divide with a calculator, we just make it look like division. So we have our fraction 2/3 x. How does it turn positive? Negative divided by negative, positive. Negative divided by negative is also a positive over here, and then we do 18 divided by 3 is 6. Hey, we could have done that for that one too. So you could have solved for y to get both the slope and the y-intercept.